So Adam suggested I do a quick discussion on phosphine in relation to the theory, the general theory. Phosphine is 1 phosphorus and 3 hydrogen. Nothing too special. I'll go ahead and read this out to you. Hi, Celeste. Phosphine is the constituent of the Earth's atmosphere at very low and highly variable concentrations. It may contribute significantly to the global phosphorus biochemical cycle. The most likely source is reduction of phosphate in decaying organic matter, possibly via partial reductions in disproportionations, since environmental systems do not have known reducing agents of sufficient strength to directly convert phosphate to phosphine. It is also found in Jupiter's turbulent atmosphere, where it forms in the planet's hot interior and reacts with other compounds in the upper atmosphere. The abiotic synthesis of phosphine takes enormous amounts of energy, such as in the planet-sized convective storms of gas giants. There are a couple things that struck me as a bit off with that. They say the most likely source of phosphine in the Earth's atmosphere is a reduction of phosphate in decaying organic matter. But then they go off on the other tangent and say, well, a whole bunch of it's found in Jupiter and Saturn. So yeah, it's produced abiotically in huge amounts. And the reason why it's still on Earth is because Earth, wait for it, is the remains of a very, very old star. And when the Earth was a gas giant and it was producing all its phosphine, some of the phosphine was left over. It's as simple as that. Venus still has some phosphine left over in its atmosphere, though it's extremely old. Again, yeah, maybe some organic processes, but if it's already formed abiogenically, meaning no life is required, then why all of a sudden is this a compound that's being singled out for evidence of life or microbial life? It's very strange. Of course, the statement here says here, a molecular mystery. Quote, it's a really puzzling discovery because phosphine, of course this is from a Scientific American off their website. It's a really puzzling discovery because phosphine doesn't fit in our conception of what kinds of chemicals should be in Venus's atmosphere. Well, yeah, I knew that. We all knew that. Says Michael Wong, an astrobiologist at the University of Washington. Planetary scientist Sanjay Limye, I think that's how you pronounce, sorry Sanjay if I mess up your last name, of the University of Wisconsin-Madison agrees. Quote, the bottom line is we don't know what's going on, he says. And then they put in parentheses here, the Scientific American article wrote, neither Wong nor Sanjay were involved in the work. Well, obviously, if they were involved in the work, they wouldn't be like, we don't know what's going on. They wouldn't want to throw their colleagues under the bus like that. But for my listeners, what's going on is that Venus is incredibly old. Fits somewhere down here on the diagram. Of course, mass is on the y-axis. So they're less massive than the Earth. Earths are up here. And they're Venus is extremely old. It still has leftover phosphine in its atmosphere from much earlier stages of evolution when it was producing a whole hell of a lot of it. And that's why Earth still has it as well. Of course, it kept its phosphine for some strange reason. I don't know why. The same reason it probably kept other types of molecules, but it's just a molecule of a very, very old dead star, a fossilized star. I don't believe that there's organic material currently forming this stuff. I just think it's leftover material. For instance, when we exhale carbon dioxide and water vapor. Does that mean that the entire atmosphere of Venus, which is mostly carbon dioxide, is evidence for people having or breathing? I mean, why did they single this molecule out? I have no idea. It's a molecule that's produced in huge amounts during the star's evolution. And that being said, I do believe Venus had life on its surface hundreds of billions of years ago. Of course, that's also blasphemy to the Big Bang religion, which states that all of existence is 13.7 billion years old, which is, of course, problematic because I have Venus between 450 billion to 700 billion years old. And that's due to its very high DH ratios and its gyrochronology. Of course, I wrote that in that paper here. I did a few easy calculations. Of course, there's more to work on with that. As well, I have here a very early paper I wanted to share with you guys, just to show you where my mind was back in 2012. For those people that don't know, I've been chugging away at this idea for quite a long time now. The Metamorphosis of Venus, of course, it's a very, very short paper, only one paragraph, but I'll read a little bit out to you. It is hypothesized that Venus is also a black dwarf star, more than likely older than the Earth. And I wrote this paper before I even did the DH ratios or the gyrochronology. The mainstream scientific establishment has no method for the formation of Venus as a nebula hypothesis, and all its variants have been falsified extensively. The nebula hypothesis and all the variants are falsified already. It is simply the leftover remains of a long dead star or black dwarf. Venus also very likely had an abundant atmosphere full of life and creatures walking among its surface and swimming in its oceans. But now it is much too hot as the surface conditions have sterilized the star. That's basically it. Of course, there are two approaches with the phosphine. Number one, it's formed abiogenically, which means it's probably just the leftover remains of when it was a much larger gas giant type star. And number two, maybe if phosphine is produced biologically, it's also what the astronomers have singled it out for, is it's evidence for life having at least been there, if not currently producing that specific molecule. But you have two approaches there. I think both approaches are as equally valid. Of course, there are other people who like to disagree with that and, be really nasty to me online and say that this general theory doesn't explain anything. Regardless, Venus is extremely old. It's the core remains of a very, very, very old star. Even though it's Earth's twin, so to speak, as they say, it's not Earth's twin. It's extremely old. It's 100, 150 times older than the Earth, easily. It has no active volcanic activity. It has no magnetic field. It's self-sterilized, which means the entire atmosphere itself has essentially fried all the life off of it. It's like 900-degree surface. So, I don't know. Like the idea that Venus still has life on it, I guess, is something that's like pre-1950s, when there are people thinking that, Venus was this tropical paradise, and that's why you couldn't, that's why the clouds were so thick. It was just a tropical paradise and we should find life on it. But then the Russians sent their probe there, which landed on the surface, and we could tell that there wasn't any life there. But yeah, I guess that sums up this talk. I'll link this paper to the bottom, the DH ratio paper, where I figure out how old Venus is. As well, I would always look at the mainstream news articles and sort of put on your skepticals, so to speak, an actual skeptic, not the pseudo-skeptics that are running rampant on the internet, where they ridicule you if you don't agree with the mainstream's interpretation of things. I believe to be genuinely skeptical, you have to question your own beliefs as well as the beliefs of others. But a lot of mainstream astronomers and astrophysicists and those types of people, they don't question themselves. They just plow forward, and they miss a lot as they go, because they make these assumptions true, which just aren't true at all. And for those listeners who are new, the main assumption that astronomers make is that the bright shining objects in the night sky are mutually exclusive of the ones that no longer shine. But we all know better. They're the same things. All right, guys, take it easy.